Hello, it's the Ethereum mob and it's Mike. Today Neo is not joining, so I may well be alone again. And I'll just go through the Solidity course by Steven Grinder. And yeah, maybe just share my screen. And I continue to lecture on. And start. First video, we're going to talk about how this course is organized. It's a very long course, so I want you to have the idea of the structure. The course is divided into roughly 4 separate sections. There's a couple of other sections here, they're just small offshoots. In general, there's 4 main parts that are going on. The first thing we're going to talk about is the introduction. In the introduction, I'm going to give you the fundamentals of Ethereum blockchains. Inside of here, you're going to get a good idea of how Ethereum works and why we care about it at all. We'll then immediately dive into creating our first working application using Ethereum. In this first application, we're going to learn how to interact with Ethereum as developers. We'll then move on to our second application. The second application is going to be significantly more complicated. And in this one, we're going to learn a lot about tooling, deployment, and testing of applications that are built with Ethereum. And then, of course, we'll move on to the last application. You can view the first 3 sections here, so the introduction, app 1, and app 2, as essentially being just preparation for app number 3. So app number 3 is where all the really, really fun stuff comes out to play. So I'm really hoping that even though this is a long course, I really hope that you can get all the way to this last app over here, because I think you are going to be really excited with how complex and how deep an application you and I are going to build on app number 3 over here. Okay, so that's just a very quick overview. And there's a couple of other notes I want to give you very quickly. The goal of this course is to teach you how to build web apps with Ethereum. That is the goal. So there are going to be some topics that we don't quite brush on quite so deeply as you might wish. In particular, we're not going to talk a lot about, say, trading cryptocurrencies. So this is not a course that's going to teach you how to invest in Ethereum or how to trade Ethereum coins with Bitcoin or anything like that. The goal of the course is to build web apps with Ethereum. Likewise, we're not going to go super deep into some of the academic side of Ethereum. So Ethereum is a very complicated subject. And there's a lot of very complex, very high-level computer science discussions to be had. We're going to kind of abridge some of those discussions. I'm going to give you a very good idea of the fundamentals of Ethereum, but we're just not going to go quite so deep onto the very academic side of things. Because again, I'm going to try my best to impart practical knowledge about how to work with Ethereum on you. So the entire idea here is how do we build apps with Ethereum? How do we make a product? That's what we're going to focus on. Now, one last topic. How do you get help? Well, there's 2 great ways to get help in this course. First off, you can always post on the Udemy discussion boards. Secondly, if you have a more urgent issue, you should always feel free to private message me directly on Udemy. Do be aware that I usually work during North American business hours, and usually I only work around like Monday to Friday or so, although occasionally I do check my private messages on weekends as well. So if you ever get stuck, I recommend posting on the discussion boards, and then failing that, send me a message directly. Okay, so that's just a little introduction into this course. Let's continue in the next video and start working on some Ethereum stuff. Now that we've gone through some administrative work, it's time to start learning about Ethereum and using it to build actual applications. In this section, we're going to start off with a little bit of a history lesson. Normally, for any technology that you learn, the history of how it was created is not always super important. For example, when you learn about HTML, you don't always learn about who first created HTML. However, in the world of Ethereum, development is changing so rapidly at this point in time that I think getting an idea of why Ethereum was created can serve to help you understand about what the project is and where it's headed. So, a little history lesson here. We're going to first start off back in October 31st, 2008. This is the first notable event. It's not actually tied to Ethereum at all. Instead, this is the date of the original Bitcoin white paper. We refer to it as a white paper. It essentially was an academic paper. It was released by Satoshi Nakamoto. The paper described the creation of a system that would allow people to pay each other directly without the need for a central authority, like a bank. Out of this paper, the Bitcoin network was eventually brought online in January of 2009. And this is the original Bitcoin network. One of the key characteristics of the Bitcoin network was the idea of a blockchain. We'll talk about blockchains in great detail throughout this course, but for now, just understand that the Bitcoin blockchain, Bitcoin white paper. We refer to it as a white paper. It essentially was an academic paper. It was released by Satoshi Nakamoto. The paper described the creation of a system that would allow people to pay each other directly without the need for a central authority, like a bank. Out of this paper, the Bitcoin network was eventually brought online in January of 2009. This is the original Bitcoin network. One of the key characteristics of the Bitcoin network was the idea of a blockchain. We'll talk about blockchains in great detail throughout this course, but for now, just understand that the Bitcoin blockchain is a tool to store a list of monetary transactions between different people. The Bitcoin network thrived and continues to thrive today. However, the only purpose of Bitcoin was to enable financial transactions. That was it. Send money from person A to person B. Not long after its release, many people realized that they could use some of Bitcoin's original innovations to not only handle the transfer of currency, but other types of exchanges as well. So one person who felt very strongly about this was named Vitalik Buterin. Vitalik authored a white paper of his own. Again, a white paper is essentially an academic document. Published it back in late 2013. Vitalik was a proponent of the Bitcoin project, but he thought that the Bitcoin project was too simple in nature. He envisioned using blockchain technology to create far more complex applications. In fact, he describes using Ethereum to create sub-cryptocurrencies, domain name registration systems, and gambling applications. So Vitalik's ideal world, he didn't want to just use Bitcoin to transfer money. He wanted to figure out some way to use these innovations to create much more advanced applications. And that's what we are here in this course to do. We're going to use this technology to build more advanced applications. Now, inside of his white paper, Vitalik goes on to describe the most important part of the Ethereum network, something called a smart contract. A smart contract is a piece of code that lives in the Ethereum blockchain. This contract can be instructed to do certain things by having a person or another contract send a message to it. These contracts are the absolute core of what Ethereum is, and we're going to be spending the vast majority of this course to learn about the behavior of these contracts. The Ethereum system eventually went online on July 30th of 2015, and it also continues to flourish to this day. All right, so that's a little history lesson. Again, we don't usually talk too much about the history of the technology we use, but I wanted to share this short creation story with you just to highlight the fact that at the very point of its inception, the Ethereum network was designed around this idea of smart contracts that operate on a blockchain, and their purpose is to allow for the creation of advanced applications. Now that we have a sense of one of the design goals of Ethereum, let's continue in the next section and start getting some experience with the Ethereum network. We now have a better understanding of one of the original design goals of Ethereum. With that in mind, we're now going to continue and start talking about exactly what Ethereum is and how we work with it. This is going to be our first description of many of the Ethereum system. And I say the first of many because this is going to be kind of a primitive, basic description of Ethereum. And as we go throughout the course, we're going to come back and address more and more complicated topics in the Ethereum ecosystem. So again, this is our first taste. We're going to come back again and again and freshen up or kind of sharpen our understanding of different pieces of this puzzle. So let's take a look at this diagram right here. Now, it's kind of a complicated diagram, but I want to focus on some of these notes I have off to the right-hand side. We're going to talk about each of these notes, starting at the top and working our way down to the bottom. I'm going to do my best not to just read the text on here. They're kind of prompts, and I'm going to discuss further about each of them. The first thing we need to understand is that when we work with Ethereum, we are working with a network of computers. These networks are used to transfer money between different parties, like you and me, and they're also used to store data. The transfer of money and the storage of data are what allows us to create interesting applications, which remember is the entire goal of Ethereum. The second thing to understand is that there are many different Ethereum networks. When you read about Ethereum in the news, you usually hear about, oh, the price of Ether coins is so-and-so dollars. Or you might hear about deploying apps to the Ethereum blockchain or the Ethereum network. In reality, there's one main Ethereum network that everyone uses for the deployment of production applications, and it's where Ether coins are actually worth US dollars, or real money, I should say. However, there are many other Ethereum networks out there. There are test networks, so networks that are used solely for testing code and testing transactions. You can even create your own private Ethereum network on your own computer that is restricted to just you. Or you can make your own network and open it to other people as well. The point is that there's not just one Ethereum network out there, there's many. And even in this course, we will be creating our own little network. Next, networks are formed by one or more nodes. This goes coupled with the next note on here. A node is a machine that is running an Ethereum client. When I say machine, I'm talking about a desktop or a laptop or any type of computer, really. So we take a node, we install some software on it, we run that software, and it connects to an Ethereum network and starts becoming a part of the network overall. All these networks connect, all these nodes connect together to form the actual network. Next, anyone can run a node. So there's not just some specific set of people out there or important companies who run nodes on the real Ethereum network. No, anyone can create one. You can create a node, I can create a node. All we have to do is turn on our laptop, download this client software, and run it. And boom, we have a locally hosted node. Each node that we create, or I should say each node on the network, has a full and separate copy of the blockchain. We haven't talked about the blockchain too much just yet, but that will be a huge topic of discussion throughout the course. So for right now, let me give you a very basic description of the blockchain. We're going to say for right now, we can think of the blockchain as being like a database that stores a record of every movement of money between different parties. And it's also where we store data. Again, the key thing to keep in mind here is that the blockchain can be considered to be a simple database and nothing else. All right, so that's our first taste of what an Ethereum network is. Again, I just want to throw some of these very basic descriptions and definitions out there. And it's going to help ground us throughout the next task that we're going to go through. So let's pause right here. We're going to continue the next video, and we're going to start getting our hands dirty in that next section. So I'll see you in just a minute. In the last section, we got a basic description of what an Ethereum network is. There was one critical part that I left out of that description though. You may have noticed that I didn't really talk about how people, like you and me, can somehow connect to this network and make changes to it, like say, send money, or store data, or do anything else. So in this video, we're going to talk about some of the different common ways that people, like you and me, can connect to this network and send money or store data. In general, there's kind of two different groups of technologies that we need to be aware of before connecting to the network. The first is technologies that are used by developers, or essentially created for developers, like you and me. So this is going to be technologies that we use to create actual applications that talk to the network through code. For that, we're going to be making use of a library called Web3.js. You can think of Web3 as being our sort of portal, or our window into the Ethereum network, and it's going to allow us to send money, store data, deploy contracts, or do essentially whatever we want to do on the network. We're going to get a tremendous amount of experience with Web3 throughout this course. Now again, this is really something that's used by developers. It's something that's used to create applications. But on the other hand, we need to be aware of people who might want to work with Ethereum who are not programmers. So people who have no programming experience, and they don't even know what programming is, they might not even really know what Ethereum is as well. For those people, for consumers, there are two great solutions on the market right now. The first is called MetaMask. MetaMask is a Chrome extension or a browser extension that allows common people to interact with the Ethereum network. The other is the Mist browser. And this is more of a full-featured web browser that is intended to be used to browse different Ethereum applications. Throughout this course, you and I are going to be getting a tremendous amount of experience with MetaMask. We're not going to use this browser quite so much because it's still in a very early beta, and some of its functionality is not quite up to par just yet. But MetaMask is a little bit more farther along development, and in general, it's easier to use. And besides that, I think it's also the most realistic way to expect common people to get on the Ethereum network right now. All right, so in this video, we spoke about Web3, which is going to be our sort of programmatic access to the Ethereum network, and we also spoke about MetaMask, which is going to be how common people make use of the Ethereum network. We're going to be using both of these technologies throughout this course to interact with the Ethereum network. Now, these two technologies are so important, and they're going to be so used by us throughout this course, that I think that probably in the next video, we should install MetaMask right away and get some experience with it and just figure out exactly what it does. So let's pause here, we'll continue just a moment, and install MetaMask and start using it. So I'll see you in just a minute. In this video, we're going to install and configure the MetaMask Chrome extension. We're going to use this extension to interact with not only the Ethereum network, but it's also going to be used by the different applications that we create as kind of a portal for our users to somehow send money or store data or do whatever else is that we require. So let's walk through the installation process. I'm inside my Chrome browser. Remember, right now, you really need to be running Chrome. There's one or two other browsers that work with MetaMask, but for right now, I'm going to show you the directions with Chrome. Inside Chrome, I'm going to open up a new tab, and I'm going to find the web store. Here's web store right here. From the web store, we're going to search for the words MetaMask, like so. We should see it being one of the first results here, and you can recognize it by the little fox icon that they like to use. I'll click Add to Chrome on the right-hand side, and then Add Extension on the window that pops up. The extension itself is very small, so it should install itself very quickly. Let me close the two windows that we're just working with. You'll now see a new icon to the right of your URL bar inside of your browser. If we click it, that'll open up the MetaMask UI. First thing we get prompted with is a couple of privacy notices and terms of use and all this good stuff, so we'll scroll through it. If you want to, you can certainly read it. Once we go through both of those, we then get prompted to enter a new password. By entering a password right here, we are creating a new Ethereum account. This account will allow us to send and receive money, and it will also in the future allow us to deploy smart contracts that we create. We're going to be creating several accounts throughout this course, so this is just going to be the first of many accounts we create. You can go ahead and enter a password here, and we'll click on Create. So I'm going to enter a password, and I'll click Create. When we click Create, we are told that something called a vault is created, and then we get what is called a mnemonic right here. So these are 12 words that form a mnemonic. We'll talk more about exactly what this mnemonic is for later on. If you want to, you can copy the mnemonic somewhere else and save it. We will, like I said, be creating many other accounts throughout the course, so you don't have to save this just yet if you don't want to. So I'm going to say, okay, I'll copy it, whatever. After that, we come to the main screen of MetaMask, and we're going to get a lot of experience at the screen. At the top left-hand side, you'll find a drop-down that says Main Network. So remember, just a moment ago, we were talking about how there are many different Ethereum networks out there. The first network that is selected by default up here is the main network. The main network is the public production network. It's where coins are actually worth something. That's where we deploy real applications that we want to use by our users. If we click on this, you can see a drop-down that also shows us several other available networks. The three networks underneath main, so Rockspin, Kogan, and Rigby, are all test networks. These networks are used to test code and to get free Ether to test our contracts with. We're going to eventually be doing a lot of work with the Rigby network down here. So this is where we are going to be deploying a lot of test contracts that we write, and we'll also use it for a lot of other purposes as well. We're going to do very little with the main Ethereum network, just because the vast majority of stuff that happens on the main Ethereum network costs actual money. And of course, during the development process, we don't want to spend any real money. We want to work with fake money, money that doesn't really matter at all. So that's why we are going to be using Rigby. Below that, you'll also find an option for localhost 8545. This is an option to connect to your local machine, so your own personal desktop or laptop. We usually use localhost 8545 when we're hosting a local Ethereum node or a local Ethereum test network. Many times development is done on local networks, so we would be using localhost 8545 down here. But like I said, you and I are going to be using Rigby a lot rather than using our own local node. And there are some very, very good reasons for that we'll iterate later on in the course. The last option you'll find on here is for custom RPC. This essentially allows us to connect to some remote network at some custom address. We won't be using custom RPC too much in this course. So for right now, I'm going to select Rigby, because that's the network that we're going to be dealing with quite a bit throughout this course. All right, let's take a pause right here. When we come back, we're going to talk a little bit more about some of the other information that's available inside MetaMask, and then we will use MetaMask to actually send and receive some tokens. So quick break, and I'll see you in just a minute. There are a couple other interesting things I want to point out about the MetaMask extension. In the last video, when we first installed MetaMask and entered that initial password, the MetaMask extension automatically generated a new account for us. So you'll see right here, it says very clearly that we are currently authenticated as account number 1. And then right underneath that, you'll see kind of a weird string of characters. Let's talk more about exactly what it means to have an account. When MetaMask created an account for us, it created an account that has 3 distinct pieces of information: an account address, a public key, and a private key. These are the 3 pieces of information that constitute an account on the Ethereum network. The account address can be thought of as essentially being like an email address. It's a unique identifier that can be shared with anyone in the world, and it tells other people who you are. It identifies your account in some fashion. Again, you can think of it as being like an email or a username. The other 2 pieces of information are the public key and the private key. These 2 pieces of information combine together to essentially form a password of sorts. The public key and the private key are used to authorize the sending of funds from your account to other accounts. So if someone does not have the private key to an account, they don't have true access to any of the funds that are assigned to that account. The account address, public key, and private key are all stored as hexadecimal numbers. So I have examples of an account address, a public key, and a private key off to the left-hand side here. Again, these are hexadecimal numbers. I can take this number right here, and if I wanted to, I could open up my Chrome console and paste it in. Whenever we enter a hexadecimal number into a JavaScript console, it'll automatically be converted to a base 10 number and return back to us. So if I hit enter right now, you'll see that this long hexadecimal number is actually the number 8 times 10 to the 76. That is an incredibly large number. That's a gigantic number, incomprehensibly large. This number is what uniquely constitutes our private key. The private key should never be shared with other people, then they can easily take all the funds that are assigned to your account. It's incredibly unlikely that anyone will ever guess your private key because it is such a large number. In fact, you are incomprehensibly more likely to win the lottery like 10, 30, 5 million times in a row than ever guess someone else's private key. Now, there's one interesting thing about the account that was created for us by MetaMask. Let's take a look at it again. So here's my account number 1, and right underneath that, the string of characters that we see are the first couple characters of my account address. So my account address is 0xCF76, and then some other characters after that. I printed out the full account address that was generated for me right here. So again, you'll see 0xCF76. So it's the same thing you see right here. I want you to do some interesting behavior. I want you to think about, say, signing up for an email address, and then go to and sign up for an address. Those two services and create an email address at both of them. You are creating two distinctly separate accounts, right? Those are two separate accounts. But in the Ethereum world, one account is used across all different networks that we ever interact with. So I can prove that to you. You'll notice right now, that, again, I'm on account CF76, and I'm connected to the Ring test network. If I change my network, however, over to the main Ethereum network, and we'll let the thing load up, when I change it over, you'll notice that my account address is still identical. So in other words, we only are ever going to work with one account, but that one account is going to connect to all the different Ethereum networks that are out there. And remember, some of the big ones to remember are the main network, Robston, Kogan, and Ring. Now, just a second ago, I said that we're only ever going to work with one account. To be precise, we will be creating several accounts throughout this course, and there's absolutely no limit to the number of accounts you can make. All I need to say is that one of networks, we don't have for each network unless we very specifically want to. Okay, so that's a little bit more about MetaMask. So we've got a better idea of exactly how we get identified and how we connect to different networks that are publicly available. I'm sure that you still want to hear a little bit more about how we send and receive Ether tokens, however. So let's take a pause right here and continue the next section, and we're going to get a little experience with sending and receiving Ether tokens. So I'll see you in just a minute. Handles accounts, we're going to get some experience in sending and receiving Ethereum coins. To do so, I'm going to open up a new browser window, and I encourage you to do the same thing as well. In this new window, I'm going to navigate to faucet.com, and I'll put the URL right here so you can read it easily. This is a tiny little website that I put up specifically for this course that will take the address of your account, and it'll send you some tiny amount of Ether specifically on the Ring test network. This will give us a good idea of what the process is for receiving tokens. After we receive these tokens, we can then send them directly back and see how that goes as well. This might seem like a very basic exercise, but there's a very good reason that we're doing it. We're going to go through this process, and then once we see it in action, we're going to walk through some of the nitty-gritty details that are going on behind the scenes, and that will give us a much better grounding in how Ethereum works. So let's give this a shot. Inside of MetaMask, I'm going to need to get my account address. So I'll open up my MetaMask window. I'm going to click the ... right here, and I will click Copy Address to Clipboard. that takes my account address and puts it on the clipboard. So I can now go back over to the browser, highlight the input, I can right-click it and hit paste, and I should see my account address placed in here. Now, your account address is, of course, going to be very different from mine. All right, now here's the interesting part. I'm going to click submit here. All right, so let's click submit. When I do so, you'll see a spinner appear on the screen. Now, that might be a little bit of a surprise, or maybe it's not. I got a quick question for you while we were waiting for this thing. Did you expect the transfer of coins here to be instantaneous, or did you expect it to take some amount of time? It clearly is taking some amount of time here, and I find that actually to be kind of interesting. The fact that it takes some amount of time to send money from point A or account A to account B is a very interesting fact of how Ethereum works, and that's going to play in directly to some of the nitty-gritty details that we're going to dive into in just a minute. After about 30 seconds or so, we'll see a message that pops up that says, great, coins are on the way. And here's the fun part. If we go back up to MetaMask, we should be able to make sure that we have the Ring test network selected right here, and we should see that we now have a balance of 0.001 Ether. Directly underneath that, you'll notice that it says that this is worth 0.7 US dollars or 70 cents. Again, don't get too excited. All of the Ether coins we work with on Ring are completely worthless. Even though it seems like I might be incredibly generous giving you 0.001 Ether here, there actually is another website very similar to this one right here, where you can freely request up to 18 Ether coins at a time, which is fantastic for testing purposes. We'll take a look at that website later on, but right now I want to use this much more easier to use version just to show you how to get some number of coins. All right, let's take a pause right here. We're going to come back to the next section, and we're going to dive into what just happened when we submitted our address to this website. So quick break, I'll see you in a minute. Our account now has 0.001 Ether assigned to it on the Ring test network. If I select the server dropdown or the network dropdown up here and flip on over to, say, the Robston network, you'll notice that our balance goes down to 0. But if we go back on over to Ring, we go back up to 0.001. I want you to recall what we just discussed 2 or 3 videos ago. We had said that every account that we make in the world of Ethereum lives in its own separate universe, like its own world, and it is completely decoupled from any of the different Ethereum networks out there. So as far as Ring is concerned, our account has 0.001 Ether inside of it. But as far as any other account is concerned, our account has 0 Ether inside of it. All these different networks can still have ties to this one singular account that we control. Just want to make sure that point is really clear. All right, so now that we have that under control, I want to think back to the process that we just went through when we submitted the form right here and sent ourselves a little bit of money. So we're going to go through the exact order of operations that went on behind the scenes when we entered our address in here. So let's go through that flow. As we go through this flow, it's going to give us a much better idea of how some of here's the flow of what happened when we submitted the address on that form. So we entered in the address and we clicked the submit button. That web page then took the address that you entered and submitted it to a backend server. This is a Node.js server that I wrote specifically to take your address and send a tiny bit of Ether to it. To make that server, I used the Web3 library. Remember, the Web3 library is a tool that we use for developers to interact with any given Ethereum network. Not just the main network, not just Ring. We can use it to interact with any Ethereum network. It's a programmatic portal that we can use to interact with all these different node things out there.
Yeah, I guess that's it. Thanks.